New process could localize Western LFP battery supply. Demand for lithium iron phosphate (LFP) batteries is rising quickly as electric vehicles and grid-scale energy storage expand worldwide. But the materials needed to produce those batteries remain heavily concentrated in China, raising concerns for Western automakers, utilities, and policymakers seeking more resilient supply chains. A new manufacturing approach from UK-based battery technology company Integrals Power could help shift part of that landscape. The company has developed a method for producing iron phosphate, a key precursor used in LFP cathodes, designed to lower manufacturing costs while enabling production closer to Western battery markets. If the process proves viable at scale, it could offer an alternative supply pathway for battery manufacturers in Europe, the United Kingdom, and North America. Rethinking how iron phosphate is produced. Iron phosphate plays a central role in LFP cathode materials, which are widely used in stationary energy storage and increasingly in electric vehicles. Despite the global growth of the chemistry, most iron phosphate used today originates in China. Traditional production methods often rely on steel industry byproducts as feedstock. While cost-effective, those inputs can introduce impurities and increase the carbon footprint of the final material. Integrals Power says its approach removes that dependency. The company has developed a lower-temperature synthesis process that uses high-quality raw materials from localized sources rather than industrial byproducts. By avoiding energy-intensive heating steps typically required in precursor manufacturing, the process is intended to reduce both emissions and overall production costs. According to the company, its UK facility has already produced multiple iron phosphate formulations that were subsequently used to manufacture LFP cathode materials. Those materials were tested at the cell level in collaboration with a UK university, where results reportedly matched or exceeded benchmark samples sourced from China while remaining competitive on a cost per kilowatt-hour basis. Supply chain pressure is driving new approaches. The push to develop alternative supply chains reflects broader geopolitical and industrial pressures around battery materials. LFP batteries have become one of the fastest-growing chemistries in both energy storage systems and electric vehicles, largely due to their durability, safety profile, and relatively low material costs. The technology now dominates grid-scale battery installations worldwide and continues to gain traction in EV platforms designed for lower price points. Data from the International Energy Agency's Global EV Outlook 2025 shows LFP batteries accounted for more than 10% of Europe's EV battery market in 2024. Adoption has expanded rapidly, growing roughly 90% year over year for 2 consecutive years. However, nearly all of those batteries are produced in China. That level of concentration has drawn increasing attention from governments and manufacturers seeking to diversify supply. China has introduced export licensing requirements and restrictions on certain battery materials and production technologies, including those linked to LFP manufacturing. For European automakers and battery producers, access to secure precursor supplies is becoming more important as regulatory and trade pressures increase. Localizing LFP production in Western markets. Regional production of iron phosphate could help enable a more localized LFP ecosystem in Europe and North America. Battery supply chains are already facing tighter regulatory requirements. Beginning in 2027, electric vehicles traded between the United Kingdom and the European Union must meet stricter rules of origin thresholds to avoid tariffs. Those rules require a growing share of battery cell, pack, and vehicle value to be produced within the region. At the same time, demand for stationary storage continues to grow as renewable energy deployment expands and electricity demand increases from sectors such as data centers and artificial intelligence infrastructure. The International Energy Agency estimates that more than 90% of global grid-scale battery installations currently rely on LFP chemistry. Integrals Power says it holds patents across more than 20 cathode active material technologies and views LFP as an area with ongoing room for performance improvements. In the near term, the company plans to supply iron phosphate and LFP samples to battery cell manufacturers, original equipment manufacturers, and potential strategic partners for validation testing. If those trials confirm performance at commercial scale, the next step would involve expanding precursor and cathode production capacity to support supply agreements across Western markets.